Hey, what's up everyone? My name is Jason Turley, and today we are going to answer this fictional request that I have here for a pen test. The note reads, "Pen tester, please test the security of this machine," and it gives us an IP address. Thank you, from the Acme Corp. And that's all we have, just an IP address to go off on. So in this video, I'll show you how to do a basic pen test, how to access the machine, exploit it, create a backdoor, and make a persistence mechanism. And then at the end, I'll give my tips on how we could make this machine more secure. So let's grab this IP address, open up a terminal. Let's scan it with Nmap, tech capital PN to ignore pings, get the service version, and then just scan the most common ports. This will take a little bit to run. All right, that Nmap scan returned, and we see that this is a Windows machine. It doesn't give us the version, but we can see up here the different ports that are open. These first three are all related to SMB, so perhaps we could use Eternal Blue to exploit it. It says it's either a Windows 7 or Windows 10 machine. See HTTP, Vuln server, and then a bunch of Microsoft Windows RPC ports that are open. At this point, we can start poking around. We can see if there's anything connected, if there's a web page or anything on this port. 5357. All right, I navigated to that web page and it says service unavailable, HTTP error 503. All right, so there's no access method here. Let's go back to our Nmap scan. All right, this is interesting. On port 9999, which is not a common port for something to be listening on, there's a service called Vuln server. Let's Google that and see what it is. We get a few results. Let's open these up. All right. Vuln server is a Windows-based threaded TCP server that is designed to be exploited. Interesting. The program is intended to be used as a learning tool to teach about the process of software exploitation, as well as a good victim program for testing new exploit techniques. Okay. It tells us how to run it. What should I be aware of? And then exploiting the program. All right, what's this next link say? It's a multi-threaded Windows app for connections on port 9999. That's what we saw in our Nmap results. It allows a user to run a number of different commands that are vulnerable to various types of exploitable buffer overflows. Interesting. Tells you how to compile and run it. And then there's different write-ups and blogs on exploiting the different functions of Vuln server. Scrolling back to the top, we see this executable, we see the source code, we can open that up. We can read through here, do our source code analysis, see if there's anything that we can exploit, or if this is just a publicly available thing. There's probably some exploits available online. However, much like your favorite cooking show, I have already created an exploit and I have that prepared here. All right, I'm in my Vuln server exploits directory, and you can see I have a number of different exploits already created and ready to go. These are things I made a while ago while studying for the OSED exam, the Offensive Security Exploit Developer exam. The one I need is this one, Vuln server buffer overflow. So I have a full working exploit. If you're curious on how I created this, I'll have a video in the description below, but it will simply connect to an IP address and a port. It'll run this shell code that calls back to my host machine that ends in IP address .137. You can see that down here in my tmux menu. And then this is just some code to actually trigger that buffer overflow, overwrite it, jump back to the stack, and then run our shellcode. If any of this looks too complicated, then it won't be a bad idea to check out that video I have linked in the description that shows step-by-step how to start building Windows buffer overflow exploits. All right, let's start a netcat listener on port 4444, because that's what was specified in that shell code And let's throw our Python buffer overflow exploit against Vuln server, see if it triggers the shellcode and gives us a remote shell connection. We hit enter. We get a prompt that says sending buffer of size 3000. And then it prints welcome to Vuln server, enter help for help, and then that exits. But on the top pane, the top menu, we can see that we connected to the target. Right? We see the IP address here, the random port, the Microsoft Windows version, and what directory we're in. We're in the Vuln server directory. I can do who am I. All right, it says I'm Jason. No surprise there. Who am I /all. We can get more information. Let me zoom in. IP config. And we can just start enumerating this box. We can start digging around. Netstat. TCP. Look at all the connections. We see our connection here. If I go back here and run a netstat on my Kali Linux machine, we can see that this matches here. The netcat listener is on port 444 and is connected to the target on 4916, and that matches this bottom line right here. This was our previous connection to that Vuln server IP address. This was our previous connection. We see it has close wait status. This is our payload hitting port 9999, which is the Vuln server listening port, and then it created a remote shell callback to our netcat listener. I've got a few notes here to help guide us in our exploration. All right, we've already enumerated the target. We could look around, see if there's any interesting files to download, any user accounts, any passwords to crack, anything like that. But I'm interested in more ways to access the system. So right now we accessed via Vuln server, but what happens if the user stops running this app? Then our connection will be killed and we will lose all access to this machine. So what I want to do is create a backdoor. So even if I can't exploit Vuln server, I still have a way back into the machine. Let me go to my bottom pane and list out user share Windows binaries, which is a directory in Kali Linux. And it has a bunch of really cool tools for Windows. What I'm interested in is in the netcat.exe binary. Now, if you're not using Kali Linux, you can download this. Just Google netcat Windows binary. Let's check it out. It's a 32-bit executable, which our operating system for the target is also 32-bit, so that works out perfectly. So what I want to do is I want to transfer this netcat binary from my attacking machine over to the target machine. And then I want to execute another netcat backdoor listener, but this time on the target, so I can call back into it. There's a few ways we can do this. I tried encoding the executable in base64 and then copy pasting it. I tried doing a web request in PowerShell, but it just wasn't working for me. So the best way that I came up with, and let me refer back to my notes over here, the fun way I found is to just do a social engineering attempt, trick the user into accessing a malicious website. So I'm going to show you how to set that up now. It's not too hard, it's not too tricky at all. All right, first thing I did, if you can see here in this bottom pane, I just came to a different directory. I called it temp demo, and I'm going to copy over that netcat executable that we saw. Just put it in a new directory, and I'm going to call it patch.exe. This is my attempt at being stealthy. I don't want to just upload something called netcat.exe to target. I want to be a little bit secretive, but if you're going to redo this scenario, you can do whatever you want, name it however you see fit. Let's start a Python web server. Sweet. Now it's listening on port 8000 globally, so anyone can come in and connect to this. But now we need the actual social engineering attempt. Let me back out of here and let's see what's on their desktop. Nothing really. They have the Vuln server directory. Then they have a 32-bit debugger. All right. Nothing crazy. Here's the fun part. Let me make this a little bit bigger. Grab this that I pre-made, copy it in here. So I'm gonna print this message. Dear employee, please visit this website, which is my IP address and port 8000 for my web server, and download the new patch to make your PC faster. Save it to your downloads folder, and then redirect that on their desktop in a file called notice.txt. Smash the enter key, do a dir, and we see that we created that text file. All right, now over on the target machine, we see that it's a Windows 7 VM. I am going to pretend to be that user. So the user's logged in. We see the Vuln server application is running. And all these connections are from the Nmap scan from earlier, plus our connection to exploit it and get a remote shell. So the user, okay, cool, they don't really care. They minimize it. And then they look on their desktop and they see notice. Oh, that's weird. Maybe the system admin left me something. So they open up that text file, and it's exactly what we typed in earlier. Dear employee, please visit this website and download the new patch to make your PC faster. Save to your downloads folder. All right. So like a good corporate employee, they follow the directions. They grab this IP and port. They copy it. They open up Internet Explorer, because that's the only web browser they have. And they navigate there. You can see here in the lower left corner that a GET request was made, a connection attempt. All right, they see patch.exe. All right, that's not suspicious at all. They click on it, and then they save it to their downloads folder, just like they were instructed. All right, that's successfully downloaded. You can see the GET request right here with the status code of 200. That was successful. We no longer need this, so we can Control-C out of it. All right, now that we know the user downloaded the netcat executable, and we know that it's named path.executable, we can confirm this. We can look in their downloads folder, and we see it, patch.exe. However, if I try to run patch.exe, it says that binary is not recognized as an internal or external command. Basically, it doesn't know what patch.exe is. It doesn't know where to find it. And that's because it will look at the path environment variable. So if the command does not exist in any of these folders, C Windows System32 or C Windows, it won't know how to find it. Ours is in the C users JSON downloads folder, which is not available in the path. It's not a subdirectory of that, so it will never find it. We could try to copy patch.exe into one of these folders, C Windows System32 or C Windows, but System32 has built-in commands that are all signed, and you need admin privileges, so that probably won't work. That's kind of risky. It's a lot easier just to update the path variable, and you can do that with the set command. So set the path equal to what's currently in the path, and then add on the C users JSON download directory. Hit enter, and now we can throw up our netcat listener. The syntax is very similar to what we did on Linux, but it's a tiny bit different. Notice the L is now capitalized. That means do a persistent listener. So usually once you connect to a netcat listener, once you close that connection, the listener also closes. So you only have one chance to access this. You only get one connection. However, the big L means keep on listening. If a connection is closed, don't close your listening end. Listen on port 54321. And once you get a connection, execute a command prompt. Hit enter. And it's just going to hang. It's not going to return. Why is that? Because it's listening. It's no different than if I ran netcat nl vp 54321 here. It's just going to wait. So now the target is listening, and I want to connect into it. Connect in, and now I have a second connection. All right, my first one is from the exploit, and my bottom one is from the netcat listener. I can confirm this with a netset command. The port 4444 was the netcat listener reverse shell, and then this is the current netcat listener that we ran on target. I know that's a tiny bit confusing and it might not make a bunch of sense. So just to reiterate, the reason we're doing this, so we were able to exploit vuln server, but what happens if the user, all right, so what happens if the user closes out of this, they have their vuln server app up, and then they exit out of it. You can see that we lost both of our connections. So that's not good. We're the hackers. We want to be able to access anytime we want, not just when that exploit is running. So I'll show you how to fix this in just a second. All right, the user has vuln server up and running again. We can run a netstat connection. We see we're not connected at all, but it is listening on port 999. I've got my netcat listener ready to go, and I have my exploit code down here. Hit enter, and we're back on target. So what happened before? We still have our patch.exe netcat on disk on the target, but we see over here, it's no longer listening on port 54321. So the only way to access this target was via the vuln server exploit. If we want to change this, let me make this a bit bigger, we can add a persistence mechanism. So Windows has a set of registry keys that tell it what to do when the computer first boots up, right? When it restarts or when it turns on for the first time, what program should it run? Some legit ones like, all right, run Spotify or run Discord every time the computer loads up. Well, I want it to run this command, C users JSON downloads patch.exe, and then listen on port 54321 and execute a command prompt. Every time it starts up, every time the user restarts, I want it to do this. There's other ways we could do persistence on Windows, but this is the one I'm going to do. So grab that, slam it in there. It says the operation completed successfully. Let's confirm that. All right, it looks good. Here's the name, not backdoor, and it will run this command once the computer restarts. All right, let's restart the computer with shutdown/R. I'm curious if we can do this through netcat. I've never tried this. Smash enter. If that worked, we should lose our connection once the computer restarts, closes vuln server. Do a task list. There we go. It took a little bit, but the connection dropped. The computer is restarting. All right, back on the target computer. I am still mimicking the end user, right? This is their workstation. They see this pop up, security warning. That's good. It's good that Windows is alerting you, like, hey, something is trying to run from your downloads folder called patch.exe. It's from an unknown publisher. It's not from us. It's not from Microsoft. We don't know who it's from. It looks really weird. It does not have a valid digital signature. So as I was talking about a little bit earlier, everything in C/Windows/System32 has a digital signature. That means it's signed off from Microsoft saying this is legit code. Don't worry about it. It can't be edited. It's safe. But this is not the case here. So this is good that this security mitigation is in place. But let's say our user doesn't know any better. They're like, hey, that notice right here, it says I should run this. It says I should download it, so it should be good. And they click on it. It pops up, listening on any port 54321, and it's just waiting for a connection attempt. Back here, I'll put my attacker hat back on. So as the attacker, I don't know what happened, if the user clicked on it, if it's running. So I'm gonna do another nmap scan just to confirm that port 54321, my netcat shell, is up and running. Hit enter, and there, it comes back really quickly. Port 54321 is open, and it's a bind shell, all right? That's really cool that Nmap is able to detect that. Now let's actually call into it. Let's connect. 54321, hit enter, and bam, I'm back on the system. I'm gonna do a who am I? I'm still Jason. ipconfig, dir, cool. So I'm back on the system. And anytime the user restarts their computer, that backdoor will be open. I don't even need vuln server anymore. So if they're not running that app, that was my original way to exploit it. But if that's gone, I'm still fine. So that's the it for this pen test. We could keep going. We could search the file system for anything cool. Try to upload like Mimikatz or something. Crack passwords. But I'm not doing that in this video. Alright, since this is a fictional pen test, I thought it'd be good to write up some security recommendations. So I jotted those down here. In no particular order, these are things that the company can do to increase their security. First, don't run Vuln server. Or if you do run it, don't do it globally. It was listening on all interfaces where anyone in the world could connect into it. We saw before that it is a well-known vulnerable program that has a bunch of exploits online. I already had one on my computer that I wrote, but it wouldn't be too hard to find one on the internet. My next tip would be to turn on the Windows firewall. The firewall was completely off. It wasn't blocking our Vuln server exploit and payload. It wasn't blocking any of the netcat connections. So we had it listed on port 54321, which is weird. There are certain ports that hackers or immature hackers will use. 4444, 54321, 12345. These should be blocked by the firewall. Only allow the ports that you need. Next, I have educate the user to not visit sketchy websites. We socially engineered them. We put a text file on their desktop. They opened it up and they went to our HTTP website. It was really just a little Python server, and they downloaded our patch, which is really netcat, and they executed it, which allowed all this to happen. The last tip I had was enable the user access control on downloaded files. So this is installed by default. This is something I had to turn off just for the sake of this demo. But when you download something weird from the internet, it's like, hey, are you sure you want to do this? We didn't see that here. We did see the pop-up when it restarted. It reran that registry key. There was a pop-up that said, hey, this is not signed. It's an unknown publisher. So that's good. You always want to make sure those things are on. So that's it for my little fictional pen test on a Windows 7 VM. You guys might be wondering, hey, why didn't you just like throw Eternal Blue at it? It's Windows 7. Well, this is a 32-bit Windows 7 operating system, and the Eternal Blue, at least the one that I used earlier when I was playing around, it only worked on 64-bit architectures, so it would not have worked against our target. Plus, this was fun. I got to show off Vuln server and just a different way to exploit a system. You don't have to use Eternal Blue for everything. Get creative and think outside the box. That's all I have for today, guys. Hope you enjoyed the video. Remember to like, comment, and subscribe. Take it easy and have a good one.